Friends, can you able to see the screen now? Students, please acknowledge me. Can you able to see the screen now?
Yes, sir.
Yeah. Right. So can I start the class? Please someone respond. Yes. Okay, thank you. Right. So there are 31 participants. Right. In the last class, we discussed about Soumya, you're requesting for annotation. Why, Nana? Right. Right. Please mute yourself. Thank you. I'm starting the class now. So there are 33 participants. Let it be no problem. Right. If you have any difficulties, please unmute yourself and ask me. Okay. So in the last class, we discussed about even signal and odd signal. So just a introduction I want to give for it. Right. If x of minus t is equals to x of minus t is equal to x of t. Right. Then it will be called as even signal. Right, minus x of minus t is equals to, right, x of t. Right, same means I have explained you about x cube is a odd signal. If I put minus x in place of it, I will get, right, so minus, okay, minus x cube. This is nothing but in place of x I put it minus x and I got overall minus. This is about odd signals. So two types of signals we discussed in the yesterday's class. Right. So I hope everyone is following my class. Can someone please acknowledge me? Are you following the class? Are you able to follow my class?
Yes, sir.
Suresh. Thank you, Suresh. Yeah, Suresh, thank you. So, what important point I have to mention? One important point. Keep in mind, please. Keep in mind, please. Okay, every signal can be represented as sum of its even and odd parts. జాగ్రత్తగా వినాలన్నా, listen carefully. I am not telling every signal is even signal. I am not telling every signal is odd signal. I am not telling, right? So if it is even, so it is not odd. If it is not even, so definitely it should be odd, right? So it means that a nahi hote o hota. There is no such scenario I am not giving here. Nenu ala cheppatledu. What I want to tell, what I want to convey, right? So every signal, every signal can be written as sum of even parts plus odd parts. So every signal can be represented of combination of odd and even. So every signal internally consists of even part, odd part. It's a summation of both. I can represent. That is a straight statement. I'm not saying that so it is odd even. Every signal itself inside of it, there are two parts are there, and one part is even part, second part is odd part. Okay, that is about my statement. Okay, so x of t is in one elementary signal, and it can be represented as sum of even part and odd part. Okay, every signal can be written like this. All right. Now, our Sai Suresh, I think. So, I'm able to see in the screen on the top. So, Sai Suresh says, sir, then can you please tell me how can I get, right? You only said, na, right? It is combination of even part. It is combination of odd part. You only said, right? So, what is even part and what is odd part? Can you please explain me? I'll explain you, don't worry. Okay, so this is about this. Okay, and one more statement that I'll explain you once after 1 month, 2 minutes. One more point I want to mention, right? Every x of minus t signal can also be written like this, right? Idi x of t, idemo x of minus t, right? I'll explain you with the example, don't worry. I'll explain you with the example, don't at all worry, right? So x of minus t is equals to x of t minus x naught of t. That means I have f of x of t, sorry, I have x of t equals to 4t square plus 2t plus 1. This is my equation, 4t square plus 2t plus 1. So I am saying x of t, this is x of t, is a combination of even plus odd. Means I can split this expression into two parts. I can split this expression into two parts. This is even part, right? And the other one is odd part. This is the odd part. This odd part. Right, there are two ways I can split out this. Okay, one is odd part, one is even part. Okay, that is first point. Second point is I will get some even part, right? I will get some odd part after this. So I'll explain you, don't worry. Wait, after this only I'll explain. Okay, so if I put x of minus t, means in place of t, if I put minus t, that should be equal to xe of t, ante e part, this part, minus of this part, it will be equal to xe of t, means even part of signal, minus of odd part of signal. So that should be equals. For any signal, whatever signal you take, for any signal it is applicable. Right. So can we go with the example? So before example, I want to tell how to calculate even parts, how to calculate odd parts. Right. How to calculate even parts and how to calculate odd parts. So to calculate that, the formula is x of t plus x of minus t whole by 2. This will give us the xe of t. That give us the xe of t. Right, that give us the xe of t. Right, means I'll explain you, don't worry. And the second part. Right, what is second part is, right, how to get x naught of t. X ante, I mean odd part. How to get a odd part in any signal. That is nothing but same expression, slight change. X of t, right, x of t minus of x of minus t, x of minus t whole by 2. Right, this is expression. This whole by 2 I have written it as 0.5. This whole by 2 I have represented as 0.5. Don't confuse that. Okay, so like this is whole, sorry, yeah, this is whole by 2. That by 2 I have represented at 0.5. Here also same. Right, so this is about, right, this is about my even and odd part. Can we go with the examples? Can anyone please tell me? Shall we go with the example?
Yes, sir.
Yes, we'll verify all these three statements. Okay, we'll verify all these three statements. Okay, I won't take big equations because it will take a lot of time only to understand the concept purpose. So we'll take a smaller examples. Okay, don't worry. So what we'll take is here I don't want to explain. Wait a second. I want to go to paint because paint will be in drawing in paint will be easy than this because right some let me give it time to open the paint. Just 1 minute. Yeah, can you able to see my paint screen now?
Yes, sir.
Very nice. So take some example. Right, is it right, is it visible what I'm writing? Is it visible what I'm writing? Can I take thicker then? No, okay, no issues
Number
then.
tick.
Okay, I'll take the thicker one then. Wait. So I'll take, is it okay now?
Yes, sir.
Yes. Okay. Yes, I'll take x of t. Okay, x of t equals to is 418. Why you people are joining so late? X of t equals to, I'll take a small example. For example, like x square minus x, that is plus 1. So I'll take x square 2 x square 2x square for example, and this will be like a 4. Okay, anything you can take. This is only for simplicity. This is only for simplicity I'm telling. Right, 2x square minus x plus 4 I have taken. Now, how to calculate x e of t, please? Even part of it, how to calculate? So before calculating it, I want to calculate x of minus t. X of minus t. Okay, x of minus t. So substitute x, sorry, completely wrong. Yeah. Sorry, the expression should be 2t square in times of t I have to write minus t plus 4. This is the expression. Anything you can take as I told. So I'm calculating x of minus t now. So how to calculate x of minus t? So put minus t. 2 into minus t whole square, how much? T square only. So it is 2t square again. And this will become plus t. And this 4 is as it is. This is example. Okay, this is x of minus t. Now, can you calculate please xe of t now? You know already how to calculate. There is a formula I have given to you. Right, what is the formula? X of t means this part, this whole part. Right, that is 2t square minus t plus 4. Right, plus, right, xo of t from formula. Do you have an idea? Right, formula. See the formula. Right, so this is the formula. Here we have a formula. See this. Right, here you have a formula. So x of t plus x of minus t. So x of t plus x of minus t. So this is x of minus, this is x of minus t, this part. Right. So it is again 2t square plus t plus 4 whole by 2. What is the answer? This minus t and plus t will be cancelled. This is 4t square plus
Plus 8.
8 by 2. This is again t 4t square 4t square, sorry, 2t square 2t square plus
Plus
4.
4.
Yeah, this is my right. This is my, yeah, this is my even part. Now I want to calculate similarly odd part. Right.
Odd part.
So, how to calculate odd part? Right. So x o of, sorry, x o of t. Right. How to calculate? So x of t, right? X of xe of t mean the same part. X of t means same part. So 2t square, same part, minus t plus 4, and here minus of minus xt. So minus of minus t means this is minus 2t square, and this plus t will become minus t, and that plus 4 will become minus 4 whole by 2.
4.
Yes, this minus 4 and plus 4 cancels. Minus 2t square and plus 2t square cancels. So what I will get finally here? Right, minus t and minus t. How much? Minus 2t.
2t.
Minus 2t by 2. So it is
2
beautiful.
to
Minus-
cancel minus t remains.
Minus
Yes, minus t. Now, right, I'm taking this one. So this is my xo of t. Right. So what is addition? I said what I said. Look at here. Look at here. Look at this part.
every signal.
Right. No, not that. Look at this part. Right. I said x of t can be written as, right, the first line which I highlighted. Look at this line, first line. So every signal can be written as sum of even and odd parts.
Odd signal.
Even and odd parts. Right.
Odd.
So see this one now. Right. Can I add even and odd part? This even part and odd part can I add? So if I add,
Yes,
so
sir.
here, yeah, I have here 2t square as my even part plus 4. Even part is 2t square plus 4. What is my odd part? Minus t.
Minus
So beautifully, see this one is the same with this. Is it rendu same kada?
Yes. Yes.
Yes
Yes,
or
sir.
no? Yes or no?
Yes, sir.
Yes, sir.
Right. So
Yes,
can I
sir.
say now? Yeah. Can I say now my expression, any equation x of t, any equation x of t can be written as sum of even and odd parts. That is the statement of this. So this part, right? So that is my this part. This part is that one. So that is this part I proved. What is the next part? Next part. What is the next part, please? Xe of t minus x of t. Xe of t minus x naught of t will be x of minus t. Can we verify that also? Can we verify that also? Yes. So we'll go with a verification then. So xe of t minus x of t I have to do. Right. So xe of t minus x of t. Yeah. So this is my xe of t. This is my xo of t. Now this is 2t square plus 4. This is xe of t. What I have in the expression? What I have in the expression? Look at here. Xe of t minus x naught of t. So minus x naught of t. So minus of this. So minus of this. So this minus of t. This means it will become minus of minus t. How much? Plus t. So this is plus t. So that should be equal to whom? That should be equal to, see this one, see this one. This is equal to x of minus t. That should be equal to x of minus t. Right, this one. See this. This is equal to x of minus t or not? Right. Yeah. Compare this part, x of minus t. Right, this one and the last which I written here. Both are same or not? Check please, these two. These two same or not? Please check. Yes or
Same,
no?
sir.
Yes, thank you.
Same, sir.
Sir.
Right. Beautiful. Yes, yeah. Right, thank you. So this is my, yeah. So this is my, this one. What? My even and odd concepts. I hope you understood it.
Short part.
Yes, I hope you understood this. Next, can I moving to the next one? Bounded and unbounded
Yes, sir.
signals. Right. So we have seen even signals. We have seen odd signals. Right. This is expression of some problems which I have given to the same problem. Now, yeah. So I want to explain bounded and unbounded. What is mean by bounded and unbounded? So this can be well explained. This can be well explained by a diagram. Right. So can you able to see the picture now?
Yes, sir.
Right. So this is one picture. The second one I'm drawing here with red color, a pink color. Right. It's pink color. So there are dashes here. Few more dashes. So what is the difference between figure, this is 1 and this is a figure 2. What is the difference between figure 1 and 2?
Figure 1 is a unbounded, sir, and figure 2 is a bounded.
Right. I think Bharat Chandra, answered. Bharat, yeah?
Yes,
Yeah.
sir.
Right.
Yes, sir.
Bharat Chandra, excellent. Nana. Good. So Bharat Chandra answered. The first one is having no boundaries for the left side and right side. So it is exists from minus infinity to plus infinity. So it should be like a, yeah, it should be like a infinite signal. Okay. What is the second one? So second one is,
signal.
yeah, second one is a non-infinity signal, restricted or bounded. Restricted or bounded. So
Bounded.
second one is a restricted or limited signal. Bounded అనడానికి లేదు, bounded అంటే ఇంకొంచెం మారుతుంది. సో అది ఇప్పుడు చెప్తాను. Right? Second one is a restricted or limited signal. Right? Time scale is limited. Okay. So now bounded కి definition దీని తర్వాత వస్తుంది. So you got the difference, I hope. Right? So I'll draw one more example now. Right? So
Sound చేయక ఇట్లా.
right. So I think, one second. Right. This is figure 1 and the second figure is 2. And I think the second figure we are regularly watching on nowadays in Aragya Setu app. Right. So what is the difference between first one? Time is sorry. Unlimited in both cases, because see here also time is unlimited. Okay, here also time is unlimited. But then what is the difference? What is the difference? Can anyone answer? By looking on to the Nana, by looking on to.
In first one, time is reducing and increasing, sir, but second one is constantly increasing.
So, right. So Bharat, I think Bharat said, so in the first one, the time is up and downs, but here continuously increasing. That you're telling, right? So
Yes, sir.
what I want to mention, what I want to focus on this, your observation is correct. But inkoncham daniki minchi nenu cheppalanukuntunnanu. Right? What is the meaning of it? Beyond that, I want to tell. Right? What is the point I want to focus on this is, look at here. Here, the height or amplitude. Here, the height or amplitude is restricted up to this, or bounded. The amplitude level is bounded here. Right? What about here? What about here? Look at this place. So it is keep on increasing. We don't know how many corona cases still increase. Right? Everyone possibly hoping that after a 1 month, or at least after a 1 year, right, there may be a vaccine, so it will prevent us from COVID. Like that, we are having a positive approach. But if the what scenario we have, the same will continue for another 2-3 years. What happened to Indian population? Emautundi? Bignesh, are you there? Bignesh, can you hear me? He's joined to the class. Someone
Yes,
please
sir.
confirm. Yeah, Bignesh. Yeah, Bignesh, respond me, please. So the same graph will extend for another 2-3 years. What happens?
So it will increase the number of deaths.
So number of deaths. So obviously Indian population will reduce, right?
Yes, sir.
So what I want to mention is, so this is, can you say, is there any boundary for this corona cases, Bignesh? Any limitations
sir.
with this corona cases, COVID cases?
No, sir.
No, why no? We have a limitation. That limitation is only social distance. So we have a limitation, but we are not implementing. Here, there is no limit for cases. So it will keep on increasing to up to what value, Nana? These are keep on increasing up to what value? These are increasing up to infinite. Up to infinite. So if the amplitude or height, so if the height extended to an infinity level, such type of signals will usually called as unbounded signals. Right? Such type of signals are called as unbounded signals, infinity extended. So with a limited, all our sine and cos are bounded between -1 and 1. Yes, all sine waves, cos waves are bounded between -1 and 1. So all these are bounded signals. Exponential signal. This is exponential, Anna. So which I have drawn, this is exponential signal. Which I have drawn, this exponential signal. This is unbounded. Exponential signal is unbounded. Parabolic also unbounded. Parabolic also unbounded. Okay. So this is about bounded and unbounded. I hope you understood. Bignesh, understood? Right. So yes. So see the picture which I have given here. See the picture which I have given here. Right. See the picture which I have given here. Someone please take the screenshots. Right. So look at the first picture, red color graph. Look at here. It was started at some point. Here it was started. Here it was started and ended with some zero. Ending it or not? Ending with some
Yes.
zero value. So this is called bounded. This is called bounded. Right. This is also bounded. Right. This is also bounded. Right. Look at these fellows. Right. Look at the second other fellows. Right. I'm circling them with a red color. Look at the red color fellows. Can you tell me when they are going to end? Is there any ending for them? No. Even our Prime Minister Narendra Modi or our favorite KCR also won't tell. Right? So these are unbounded. These are unbounded. Right? Red color or unbounded. Blue color or bounded. By looking at the figure, you can
Bound.
understand. Right? By looking at the figure, you can understand, I hope. Yes? Can I go with the next?
Yes, sir.
Right. So the next one. Right. The next one. Power and energy signals. Right. Power and energy signal. Right. So what is mean by power signal? What is mean by energy signal? Right. So usually what is mean by power? What is mean by power, Nana? Can anyone define what is
In
mean by
general,
power?
power means voltage into current, sir, in physics or in BW.
Excellent. So P equals to VI. We'll use it for several times. Right. Very nice. Very
Yes,
nice,
sir.
Nana. P equals to VI. So if you don't like V, you can replace into I. If you don't like I, you can replace it into V. So there are 3-4 formulas we have seen for power. Right. Obviously.
Yes,
So
sir.
in our ECE, we don't like to use currents. We don't like to use currents. So for power calculations, for power, and I mean current will use, but for power calculations, we'll prefer to use only voltages. Only voltages. So we'll prefer P equal to, right? P equals to V formulas. Okay, P equals to V formulas. V squared by R. Okay, so usually. Right. So these are power, right? What is a power of a signal? Power of a signal. What is a power of a signal? Right. So you know, as our friend Bharat said, P equals to VI If you don't want I, how can you convert V equals to IR? Mr. God, Ohm's law is a God, right? Mr. God said V equals to IR, I equals to V by R. So R here. So this is my, right? This is better, right? Okay, so I can put my R here. So this is my R. So if I substitute it here, so this P will become V square by R. This is my, yes, this is my P. Right. So there are power and energy signals. I'm not talking about, I already explained what is power, right? What is power? I have already explained how to calculate power of a signal. That also will calculate. Look at here, right? Carefully look at here. This is a beautiful waveform, right? And it's peak to peak voltage. This is called peak to peak. This is called peak to peak. This is 2 and here minus 2, for example. So the peak to peak voltage here is 4. So put V equals to 4 in this expression. 4 square is 16. Okay, and resistance usually will take 1 ohm. Right, so this is 16 watts. This is 16 watts. 16 watts. So this is your power of this signal, power of the signal. Right, this is power calculation. So my interest here is, right, some signals specifically called as power signals, some signals specifically called as energy signals. Then what is the energy? Can anyone answer? Power you understood. What is energy? What is energy?
Product of Planck's constant and frequency, sir.
Very nice. But is it understood only for few people? Right, it will be understood to the few people, right? So maybe Pavani understood, Srijana understood, but her sister is there, one sister, she's from BPC background, right? She won't understand, right? She won't understand because they are having a less grip on this concepts, right? So what happened, right? So what happened, so this type of explanation may correct only, but exactly will not apply to understand. So energy means the amount of power utilized to do some work. Simply not understood, right? Not understood. Look at here, right? So this is my book. How much amount of energy, power, or my energy, the amount of energy, or sorry, the amount of work done to hold this book. This is work. The amount of work done to hold this book. So work ante meaning ante malli energy ane vastadi. Kaapothe energy enta spend chesam deen moyadaniki ante malli meer confuse avutaru. So the amount of work done to hold this book is termed called as energy. So it says that energy and power are interlinked. Energy and power are interlinked because if I don't have a power, Nana, please mute yourself. Right, if I don't have a power, I won't hold this. If I have a power, among them some energy I spend to this book to hold like this. So this power and energy are interlinked. Okay, so this is usually physics only. Fine. So in our signal system, some signals are called power signals, some signals are called energy signals exclusively, right? What separate is a separate category, right? How I say is, look at here, in the class there are 49 students, but I am calling two people as CRs. So they are students only, but CRs. So here these all are signals only, but power signal, energy signal means some special quality they have, some special property they are exhibiting. That's the reason I'm calling such signals are power signals and energy signals. I hope you understood why I'm calling them as CRs. There may be some special quality. Here also some special properties. Here also it has some special properties, special qualities, and those type of signals are called power signals and energy signals. So in the next class, not now, in the next class, because it's classification, We'll verify how to verify energy signal, how to calculate power signal, how to calculate energy and power. This we'll discuss in the next class. These are only classifications. These are only classifications. I'm repeating, these are only classifications, right? So next, right, fantastic. We are moving to the very important. You can put 100 V's before it. Very much important. Nana, please mute yourself, Padma. Right. So elementary signals. What is mean by elementary? Why I'm calling these are elementary? These are like our elementary school. Elementary school means manaku 10th class. How 10th class or SSC or 10th means that what I call some metric. So how the 10th is very much important, because see, whatever formulas we have studied in school levels we are using nowadays, the areas and the perimeter, circumferences, circumstances, everything. What are the basics, formulas, trigonometries, right? All this geometry, everything we studied in the school levels. That is elementary level. That is important to study the BTech, right? So to study the signals and system, these are basic signals, right? Signals means shapes only. Don't confuse, Nana. These are, yeah, these are like signals only. These are some signals only, like this, some signals only, like this, some signals, right? Like this, some signals only. But these signals are very much special. These signals are very much special. You know how much special these are? How much special these, you know? So if any one of our student, will become a CEO of Apple or Google or Oracle, then we can call he's a special, right? Any one of our student will become a CEO of Facebook, CEO of Oracle, CEO of some Google, Sundar Pichai, right? Like our Mahesh Babu, right? So how he becomes special like that. Some signals are having special because of their nature, because of their behavior, So there are around 13 to 14 signals we are going to discuss, right? ఈ 13-14 కూడా ఏంటి? What are these 13-14 are different characters, like different special signals. Don't confuse. So all are signals only. Those among them, few of them are important, few of them are regularly will use. So we are focusing on them. The very first one among them is step function, right? Step function or step signal. So this is origin 0 and this is a step signal. Sorry. What is the beauty on this? Can anyone please tell me? Deepti, are you here? Are you there in the class, Deepti? Deepti. Yeah. Deepti is not here. Then Shreya, what is the speciality of this, Nana?
It is constant, sir.
Right. Beautiful. Why I'm focusing this? Because there is one beautiful property that, right, time. This is time, Nana. This is time. And this is my voltage or amplitude. Voltage or amplitude. There is a difference, Nana. There is a difference between voltage and amplitude. Don't confuse. Right? And magnitude also. This is amplitude. We can also sometimes call magnitude. Everything is different. Okay. So, I'll use one time once. Don't confuse. I may use sometimes voltage. I may use sometimes amplitude. I may use sometimes magnitude. So, sometimes I may use height. Right. So, right. Look at here. The height or amplitude or voltage at every instant with respect to x, right? Every time with respect to x is a constant. This height is constant. This height is constant. Look at here. This is constant, right? Means, for example, it is 2 all over from minus infinity to plus infinity. It is plus 2 only, right? It is plus 2 only. This type of signal is called step. Right? Can anyone see this type of signal in the real life? Have you seen this type of signals in real life?
Yes, sir.
Where? Sai Suresh?
After the person's death, state sickness.
After
After the person's death, sir.
after the person's death. Why? How? See how it is stable. See, don't misunderstand me. He's a person, right? Nakanta, I don't know much drawing. Please excuse me. I'm very poor in drawing. Yeah. So he's a person. Let it be a friend of Sai Suresh. Okay. So don't misunderstand me. Sai Suresh was comedy only, right? So he dies now. If he stop, if I left him, yeah, please. Yeah, if I left Sai Suresh, mute yourself. Yeah. So if I left him in the road, will he be same way for another 1 year? Can anyone answer? He'll be same
No.
way.
Sir.
Then how can we say a death body is stable? He don't have a movement, but the bodies will be same state. Never. Right. So in your real life, there is no step persons. There is no step things also. There is nothing step. Temperature changes every time. See, the temperature changes every time. Right. Our brain, our thinking ability always changes. Our behavior always changes. Our study always changes. Our government changes. Today KCR, yesterday KCR, tomorrow maybe we don't know. After 20 years, KCR may not be here. Okay? Right. So, is there any constant things you can observe? Never. Right.
No, sir.
Right. But remember, I told you already. Right. So, I'll stop with this. Right. But you know what? From here to here, if I observe, from here to here, right? What a box. So, I'm drawing a box. In this box, if I observe, up to this box, it is stable or not? Yes or no? Up to this line, up to this it is constant or not?
Yes,
Yes,
sir.
sir. For particular
Ah.
time period, it is constant.
Excellent. Can you now give an example of this? Can you please give me an example of this? ఈ టైం కొంత సమయం వరకు స్టేబుల్ గా ఉంటుంది. Can you give an example of it?
Solar systems are planet rotations.
No, planet rotations are always periodic. Planet rotations are always periodic. Nana, Bhumi every moment తిరుగుతుందన్న, how it is stable? Every microsecond, millisecond it is rotating. Right.
But అది కాన్స్టెంట్ గానే రొటేట్ అవుతుంది కదా సార్, దాని
Yes.
ఆర్బిట్ లోనే.
Then you have to mention speed. Right, speed. Okay, and one more point. Yeah, so this we'll discuss tomorrow because there is no time. So I'll give a beautiful example for this. Tomorrow we'll see. Right. So meanwhile, please send me the screenshot of your participants. Please share me the screenshots. Next class, when you're coming, everyone should be like this. How you're renamed. Right. See the Pavani, how she Pavani renamed. Like this, you should come. And some students, I don't know who are them. Who is that? Sairam? Pavu Pinniti Sairam. Please rename. Rename first your number, then your name. Right. Some people are not at all even renamed. Okay, please rename as your number first, then your name. Right. The next class we'll see. Thank you. The time is about to end. Right. See you in the next class. Thank you.